Good morning. Thank you for having me. Today I'm going to talk about innovative GIS in the construction of Sydney Metro West with a subtitle of The Early Onset of Grey Hair. Thanks. So I'm going to take you through the project overview, describe what we were required to do, and then talk about the requirements we had, the solutions we envisaged, and then how we deployed them. So the project that we have completed is twin 11-kilometre rail tunnels from the Bays, which is basically Anzac Bridge, all the way out to Olympic Park. We had two 7-metre in diameter double shield hard rock TBMs, and as you can see, they're pretty big. So for scale there, we've got full-size burly construction workers standing next to them. We also had to excavate and complete civil works on 5 different new stations, which are about 300 metres long and 30 metres deep, which is about 250,000 cubic metres of rock. So a lot of work to do there. And also we built 2 precast yards for more than 70,000 concrete segments. And so the overview of our GIS on this project is that we used ArcGIS Online for all of our data hosting and serving, and we used Vertigis web viewer for our web mapping, our corporate web mapping component. Unfortunately, ArcView has been retired, so we're using ArcPro as our desktop GIS to basically construct all of our work. And our cloud ETL was using FME Flow hosted, which is kind of like the centerpiece of what we'll be talking about today. And so our deployment on this project isn't just, here's a bunch of construction lines, let's go. We're deeply embedded into our construction projects now. I know that some of you have probably witnessed that digital engineering was an afterthought, but now we're actually a much needed requirement. So our Vertigis uses SmarterWorks so that our real-time, our dial before you dig inquiries are always available to us. Our environmental team used it for approvals when it came to low impact works and our heritage and environmental constraints. We also use it for our property condition survey. Some of our tunneling is only 15 metres underground, so we have to perform dilapidation surveys. So one, we don't damage people's property, but if we do, we actually come back and fix it for them. But the third part is that some people try it on saying, well, there's a crack in my walls. Like, well, we got a photo of it here. No, there wasn't. Thanks for coming. Same with our construction progress. We had to measure our tunneling, our groundwater monitoring, as well as noise and vibration. All of our sites, we used a mix of MetroMap and drone flights, and also our site operations, so we could have our traffic management available for everyone to see, as well as our site plan layouts as well. But the main innovation we're going to be talking about today is how we manage our project defects. Clearly, that's a good use of AI, that man with a giant clipboard, but basically a defect, it was kind of news to us, but it's pretty much part and parcel of any construction project. And so basically anything that we construct can potentially have this issue, so it's taken quite seriously. The other thing that we needed to innovate on was TBM tracking, which I'll go through towards the end. So we needed to show the whole project where the TBM was, where it has been, and where it will be soon. And also, we had some critical data automation around our utilities that would come from survey on a bespoke notice period. So the requirement elements we had, we engaged our internal quality team, and they basically sold us the vision of what needed to be done. And then we just went through, broke it all down. But they had a few non-negotiables. So one of them was that there needed to be a one-to-many relationship. So there had to be one inspection, but then multiple defects captured against that inspection. I think you know where that's heading. The defects also had to be in SharePoint, which was new to us as well. That was a non-negotiable, and that's because the quality team who'd done work on City Metro, City and Southwest had done all their reporting in SharePoint, but they didn't have a GIS capability to help them with that. Also, the defects needed to be in a central place inside the GIS so that everyone who was part of the defect lifecycle could do their work and progress it to the end. And also, the best innovation we thought in terms of the requirement was how we used the GIS for client sign-off, which I'll get to soon. So the scope of defects was the one that really kind of terrified us. They installed 12,000 plus tunnel rings. And so that took us 18 months to do, and we finished it fairly recently. And that equates to over 70,000 plus concrete segments. They all weigh 1.5 tons each. And again, they have like dowels for connecting, different edges, different gaskets. There's a lot of ground to cover. And so this happened 24/7. We also had to build cross passages where they pull out the tunnel that we've just built and then mine through it, put in formwork, waterproofing, concrete again, a different scope of defect management, and also service works around just civil works for primary access and things. And so this is the defect management workflow. And you know what? It's really complicated. I still don't understand it to this day, but we managed to get there. So I'll break it down for you. It's that defects get captured in our mobile GIS. They get sent into our central web system and our FME flow platform to do all the data processing that enables our quality engineers to progress through the workflow process. And then finally, we let the client into one of our AGOL web viewers where we could enable them to update the defect once they'd considered it to be complete. And this was the framework of our solution. So you can see here, ArcGIS Survey 123, which is getting a good run today, up into the platform, JSON webhooks to our FME server and to the quality team's Power Automate. And then they put their stuff into SharePoint, we put our stuff into SharePoint, and then we also went into ArcGIS Online. So it was pretty tricky to start to have to use two systems and have them in sync, but you know, it's still ongoing and working to this day. And the JSON part here is webhooks, which is sort of a favorite of mine, which I'll talk about it to you in a moment. So yeah, surveys 1, 2, 3, as we've all seen from Matt's excellent presentation, it has mandatory questions. So just to set up the environment here for survey 1, 2, 3, you're up to 70 meters underground, it's 3 in the morning, it's really hot, and you're working around heavy machinery, and there's a requirement to ensure that you have enter data correctly once and enter it well. So we managed to utilize survey 1, 2, 3 to have mandatory questions so they don't forget. It tells them to come back and finish something. We have drop-down controlled lists. We have a GPS map location, and also we're able to call variables. So they don't have to remember what date it is, who they are. It pulls in their own login name to make it as easy as possible. We also found that we wanted to utilize as much of the screen space as possible. So filling out the inspection information was good because we could then collapse it and get all the screen space back. Another requirement from the client was that they needed to record inspection. So we allow them to pick themselves, write their name, and sign off as we saw before. And the most important part was this one-to-many captures. So we allowed them to pick their tunneling section, pick their cross passage, or pick their ring number, and then capture the photos on the device, and then use the one-to-many facet, which really was what this all pivoted on. We couldn't use field maps for that because, it's sort of an edit process, but this is a capture. And so, we all know it goes into Survey 1, 2, 3 web platform where we can preview there. We can do reporting. But the best part about this that we leveraged is the REST API for reporting. And we used FME to leverage that. So when the survey got submitted, Survey 1, 2, 3 picked it up, and then it sent the webhook trigger to our FME server, which then ran a workbench. And so it allowed us to capture the JSON packet, call it with FME via HTTP caller, trigger the report, it would process the report, it would then allow us to download it and then send that off to SharePoint. So again, all the GIS people are asleep, the tunnels are underground doing this work, and their report automatically goes into SharePoint for the quality team untouched. And yeah, we all know how easy it is. It just comes out in a PDF or a doc. Everything that got captured in Survey 123 is all there in the form, the signatures, the photos, the descriptions, and they're dead simple to make. You just generate it in Word, update the field names, and off you go. And so for the uninitiated, a webhook is basically, it's Survey 123, the web platform has the capability to send webhooks. And so you can see here, not very clearly, there's a Power Automate link and there's also a separate link as well. So a webhook, is the way I understand it, is a private email for data, like a sort of your own private system. So you get the event triggered, which is Survey 123, which is a survey being submitted. It gets the request with the JSON payload, and then it processes it. So for us, as we see here, Survey 123, it picked it up, sent it to our FME server, and automation took that, triggers a workbench, and then all the information gets processed, ready for deployment to our defect layer in our GIS, which is then to be consumed by our web map. And so here is an example of our ETL. So I think if I can get this right. So as you can see here, this looks pretty complicated. But it allows us to do a high level of processing and data function, again, while we're all asleep in our beds. So we take the Survey 123 data, we combine some lists, we bring it all back together because we had a one-to-many relationship with our clients back to the inspection itself. We then filter by the inspection types that all have different forms and different questions, but all have to go into the same defect management layer in AGOL. And one of the problems we had that we're proud of is that you can't get a GPS position in a tunnel under the ground. And so we thought about how can we solve this? And so with some help from our FME guru, Leon, we managed to get all of the tunnel ring numbers from the engineers put into Survey 123 as part of a drop-down, and then we managed to get from our designers a control line of the tunnel and then find out the width of a tunnel ring, and we generated our own schematic of the tunnel rings and matched up the numbers, and then we got a geoid of an X and Y of each one. So we had a spatial list of where the rings were, and then we had ring numbers as they came in. So as the defects came in from Survey 123, we basically had that CSV in our FME server. We joined them up. FME updated the geometry of the point and then moved it to the concrete ring. So basically, as long as you put the right number in, you could have submitted it, in a completely different country, and it still would have ended up in the same spot, which then allowed our users to know exactly where it was. And so we write to our hosted feature layer, we do a little bit more processing, and then we trigger extra workbenches. And so our defect management IDs had to come from SharePoint, so we open up another workbench which pulls them down, and then also attachments don't come through, so we have another workbench where we pull the attachments down, and then because of that one-to-many, we then put them all together and then put it on a single defect. So there's a lot going on there. And so yeah, this is the cake that we made with all those different ingredients of all those functions. So these are the defects so far. You can see the green ones, a lot of them are closed. But, and so everything from Survey 123 is in this attribute table. And then also it allows them to edit it and move it from QA review to a repair update and then to client sign-off. But we can also allow our users to generate reports from this central web map as well, web application, sorry. And so they too can generate defect reports that just get handed to the client. So every month we send them the reports. So it builds a trust relationship where they go, well, how do we know what you're doing? Well, here's 1,000 PDFs. Have a look yourself. But then we also can generate repair sheets. So our people in the repair team will then go out and just look at the sheet and, because in a tunnel, an iPad can break, it can go flat, it's, all those kinds of things. So they preferred the technology of paper, which we had to agree with. And so, yeah, they have a list of what to go through. And then this is their repair sheet. So they mark this up by hand. Again, we've found that some parts of the work we could do with iPads underground, but repairing a crew covered in concrete, covered in glue, big gloves, whatever, they just use a pen and go from there. And so in the end of all this, as part of our innovation, a lot of things changed for the business, for us, and also the quality team. So delivering this was not a nice to have, it was part of our delivery scope. So it was a bit do or die, to be honest. And also it was mandatory for completion. So if we didn't hit our handover targets with our defects, we didn't get paid, but also we got fines if we were late. And the defect reg was a contractual requirement. And so, putting all this together allowed us to show them whenever they felt like it, they could just open their laptop and have a look about it, how our process was going. And also it also built a new partnership. So the quality team was like, we've heard of GIS, what does it do? Come help us. But I didn't know what a defect was really before we started. So it allowed us to get an understanding of each other, and already we're collaborating much better on Western Harbour Tunnel and our energy projects. But the best part of this is that the WebGIS is the client sign-off. There's another one of those custom apps when we just give them AGOL invites, they sign in, and when it comes to configuration of the app, they can only edit 3 columns, and that's closeout date, closeout user, and whether we've accepted to be a defect or not. So it also allows us to sort of hold each other to account, and we also use it in our monthly quality teams meetings. So when there's a bit of a dispute, we just go, hang on, let's look what happened. We put it on the projector or the Teams call and go from there. So yeah, this is a new standard for us. There's no delay in transmittal. Our repairs get applied sooner. There's less wiggle room to get our responsibilities, and also we can show what we're doing. I do have other things around our TVM tracking and our critical data automation, but my time is up, unfortunately, but we're more than happy to speak to you during lunchtime or after the break at how we used FME to project our tunneling, and also how we used our webhooks and automation to do our critical data automation. Thank you.